Good evening, everyone. Myself Gautam Sharma. I welcome you all on behalf of Sapiens Education. So today I am going to discuss about the ray optic, and this is the part one video of the ray optics. For more details and other chapters, you can go to our playlist so that you can understand. Now let's go for ray optics. So what is ray optics? What is ray? Before that, we need to understand what is ray. A ray of light is the straight line path followed by a light in a going from one point to another. The ray optics therefore uses the geometry of the straight lines to represent the macroscopic phenomena like rectilinear propagation. As we know that electromagnetic wave is like this, so it will be waveform, but the direction of propagation of electromagnetic wave is in a straight line. So basically for macroscopic, for large phenomena, we will only use straight line. We won't use this curve. So, and all this we will study in the ray optics. Now, before that, we need to understand what is the reflection of light. It is the phenomena of a change in the path of the light without any change in the medium. Okay, let us consider this is the incident light, and again after striking, it will again go to the same medium. So striking back to the same medium. Okay, striking back to the same medium, and this is known as incident ray and reflected ray. So this phenomena is known as reflection. This phenomena is known as reflection, right? Now laws of reflection. First law of reflection is angle of incidence is equal to angle of reflection. So let us consider this is a plane mirror or anything, and a ray of light which will strike. So what will be the angle of incidence? So angle made by the normal. So let us consider at a point of incident we have done one normal. So it is making an angle of incidence I. Now what will happen? It will get reflect back in the same medium like this. So this is your incident ray and this is your reflected ray. Reflected ray. So what will happen? It will reflect back in such a way that the angle of incidence will be equal to angle of reflection. That is angle I is equal to angle R. If angle I is 30 degree, so angle R will be also 30 degree. Okay. So this is the first property. Second properties. Second property is incident ray, reflected ray and normal all lies in the same vertical plane. So let us suppose this is a point of incidence and this is the incident light, and when you observe over here, so if you consider this as a plane, so if all incident ray, normal as well as reflected ray all must lie in the same plane, right? Now let us talk about the spherical mirror. So you know that spherical mirror, let's talk about the spherical mirror. A spherical mirror is part of a hollow sphere whose one side is reflecting and other side is opaque. Let us consider there is an hollow sphere. Let us consider there is an hollow sphere. Mm, this is a hollow sphere and either of the side is reflecting. If suppose this side is opaque, so this side inside surface will be reflecting, and when you cut this, so you will get a mirror. So basically mirror will be like a disc like structure. So this is the mirror and this is considered as a concave mirror. When reflective surface is outside, so it will be considered as a convex mirror. So concave mirror whose reflecting surface is toward the center of the sphere of the which mirror is the part. So I hope you have understood this. Now let us go for the convex mirror. It is a mirror whose reflecting surface is away from the center of the sphere. So it is a this is your reflecting surface and it is your center of curvature. So center of curvature is in this direction, but reflecting surface is in this direction. Okay. So as we have already discussed that light is considered as the ray which travels in a straight line. Geometrical optics states that for each and every object there is an image. It works on the following assumptions. So these are the assumptions we will make. That is one. First one is rectilinear propagation of light, that is light ray travel in a straight line. Okay. Next is laws of reflection. We will study about laws of refraction. After that we will discuss about the physical independence of the light rays, that is two light rays are totally independent of each other. If there is a one light ray is like this and another is like this, so both are independent, right? So there is no collision, there is a no relation between these two light. If intensity of this light will increase or decrease, so it doesn't affect this light rays. Now let us consider a reflection of light. Reflection is the phenomena of a change of the path without any change in the medium. So the returning back of the light in the same medium. See, this is the incident light and this is the reflected light. So this light will return back to the same medium. So this phenomena is called reflection of the light. It is angle of incidence I and this is angle of reflection R. So the incident ray, reflected ray and the normal to the reflecting surface that lie in the same plane. When we talk about the same plane, so we are talking about this plane. Now laws of reflection. The laws of reflections are given below. So we have already done this. Angle of incidence is equal to angle of reflection and all lies in a same plane. So we have already taken this. Spherical mirror also we have done this. So this is a polished surface. Okay. So spherical mirror whose reflecting surface is a part of a hollow sphere. Spherical mirror of two types, that is concave spherical mirror and another part is your convex. So we have already done this. Now there is one more important sign convention. So this is very much important. Sign convention, before that you need to understand that let us suppose there is a mirror like this, an object is placed, so the all the distance of the object can be, every distance can be measured from the this point. So this is known as pole. So this is known as pole. So when there is an object, so try to understand over here so that you will get clear picture about the sign convention. Okay, so sign convention. So see here, let us consider this is a mirror. Okay, and there is an object, which is kept at this point. Okay, there is an object which is kept at this point. So if you want to find an object distance, you have to consider first of all pole. So from pole only you have to do the give the object distance. You have to take the object distance. You have to measure the object distance with reference to pole only. So first of all, if an object is placed here, so you need to observe that what is the direction of light. So definitely direction of light is from left to right. Now you want to measure the object distance, so you have to visit first of all pole and you need to move in this direction. Since in this direction you are moving, so any distance you are taking in this direction which is opposite to the direction of incident light, that will be considered as negative. So from this we can observe that the object distance will become negative. Now if you talk about the focal point, so let us consider this is the focal point. So if you want to measure the focal length, so from here what will happen, it will be f. So this is the focal length. Got it? This is the focal length. So focal length will be negative. Why? Because when you start moving toward this, so focal length, so what will happen, you have to take opposite because you are going in opposite direction. Now let us suppose an image is formed at this point. If you want to find the image distance, so you have to take it reference from this point. So when from while going from this to this direction, so this is the image distance. So see, when you are going to find an image distance, so what you have to do, you have to go in the direction of the light. So it means image distance will be positive. So this is way, if you are going with the direction, if you are going with the direction of the light, so it is positive. If you are going against the direction of the light, so it is negative. And always try to remember that wherever you are, just you have to first of all you have to come at the pole, and after that you have to measure the distance in that particular direction. You cannot go just simply go an object, you cannot find a object distance just by moving in this direction. First of all you have to go at and stand in the pole, and you have to move toward what the physical quantity, or toward the quantity for which you want to measure. For example, I want to measure the distance of the image, so you have to go in this direction, so the match the direction. Okay, so direction of incident light. So, and against you have to take negative, and width you have to take as positive. Upward you have to take as a positive, and downward direction you have to take as a negative. So with this, it is very important that you have to remember all this point. Now what is focal length? Focal length of the spherical mirror. So when we talk about the focal length of the spherical mirror, so a parallel beam of light which is either parallel to the principal axis, or beam of light which is falling on the mirror, will reflect back, and they will meet at each point. See here, all reflected light will meet at the point, or appear to meet. Appear to meet. That point is known as focus point. So see here, it is not meeting at the principal axis, but the plane which is passing through this point will also pass through the principal axis. That point is known as focus point. So focal length, if you want to find a relation, so focal length is equal to r by 2 only. Okay. Now what is real image? When we talk about the real image, if rays emanating from the point actually converge to at the other point after reflection, or that point is called the real image. Let us consider this is the mirror and the object is kept here, and due to this what have happened, and we are getting an image at this point. So there is a real ray of light which is meeting or converging to form an image. So this image is known as real image. But when we talk about the virtual image, so virtual image, what happened? Let us consider this is the mirror and this is the principal axis. This is the mirror and this is the principal axis. Let us again draw this. Again draw this. This is the mirror and this is the principal axis, right? And there is a pole. So this is the pole. And let us consider this is an object is being kept here. So when object will light will goes like this, so it will again like come like this, and it may pass like this. So what happens? Actually see, light won't get converged, so definitely they are not going to meet. But when you observe from the back side, so you will find that the image is forming, image will appear to be from back side. That is virtual image if rays emanating from a point do not actually meet but appears to diverge. So when you observe this point, so from this point, these both rays appear to diverge. So that means it is your virtual image, and there is no actual rays of light is involvement. No physical light is involving in formation of this. Irrespective of that, we have already done in the real image, right? So I hope you have understood this. Now let us talk about the mirror formula. What is the mirror formula? It is a relation between the focal length of the mirror and the distance of the object and the image from this. Now first of all, you need to understand. Let us consider A and B. A and B AB is an object. So let us put here it is an object, and when three rays of light appear, so it will form an image, and this is known as A dash image and B dash image, right? Now see here, you have already understood now. Now we will use this to derive some of the relation. U is the object distance, B is the image distance, F is the focal length. So these three things. So we want the relation between these three things. Okay. So before that we have to do some of the calculation, and we have to assume it. So we have already uh, assumed so many things. So here, as in triangle, let us see triangle ABC and triangle A dash B dash C. So which triangle we are talking about? ABC means this triangle, A dash B dash C. So this triangle we are talking about. So since both have a opposite interior angle similar, this one two angles are same. So these both are similar. This both triangle are similar. Are similar. So if both triangle are similar, so can we write the relation AB divided by A dash B dash is equal to CB divided by CB dash. So this is equation 1. Again, in triangle ABP, what about ABP? When we talk about ABP, this is the triangle ABP. This is triangle ABP. Okay. So in triangle ABP and triangle A dash B dash P are similar, so that AB divided by A dash B dash is equal to PB divided by PB dash. So we have already got two triangle, right? So which triangle we are talking about? This one. See, this one we are talking about, and we are talking about this triangle. So in this both triangle, both are see two angles are same. These are perpendicular are same. So from this we can find this relation. So this is equation 2. Now by using these two equation from equation 1 and 2 from equation 1 and 2 from equation 1 and 2 we can get, let us see, CB by C B dash is equal to PB by PB dash. From back side you can observe, see here, because AB by AB dash both are equal, so definitely this one both will be equal, so that's why I have equated this. Now by measuring all the distance from P, by measuring all distance from P, all distance means this pole, we distance, all distance from P, that is from pole, this pole. I have already told you in the previous section that you have to take all the dimensions from pole only, right? So from pole we have can we write CB is equal to PB minus PC, see here, and CB dash is equal to PC minus PB dash, see here, CB is equal to CB is equal to PB. This length will be equal to whole PB minus this one PC. CB dash, this one can be written as this whole one length, that is PC minus PB dash. So this we have written, right? Okay. So I hope you have understood this. Now from this, now we can put now at this position. So just put the value of this both. So what we will get, see here, we will get from equation 3, let us consider this is as equation 3. So from equation 3, put the value of CB and CB dash. So we will get PB minus PC divided by PC minus PB dash is equal to PB by PB dash. So this is fourth equation. Now using Cartesian convention, Cartesian sign convention, by using sign convention we get PV. Let us see, PV is equal to minus U, where you can observe PV, see here, PV is equal to minus, see here, PV is PB, when we talk about this PV, so this is an object, so object distance is U minus U as per the sign convention. After that we can PC is equal to minus R, and P B dash is equal to minus B. So so we need to put all the values in this. So when we will put this, so what we will get, we will get, see again I will write for you, I will write again one same equation. First of all, PB minus PC by PC minus PB dash, and this is equal to PB divided by PB dash, right? Now put the values. So PV is equal to minus U plus R, because it is minus minus will become plus. So this will be minus R plus B, and this is equal to minus U by B. Now when we equate this, so what you will get, minus we will get, see here, just when you multiply it, so this will be UR minus VU is equal to minus VU, sorry, it will be, this will be minus B, na? Okay, so yeah, it will be, see here, multiply it, minus VU, so it will become VU minus VR. So from here we can rearrange UR plus VR is equal to 2UV. Now by dividing both side by UVR, we get 1 by V plus 1 by U is equal to 2 by R. So just put this value, so we will get 2 by R means what, focal length is equal to R by 2. So for just you put this, so 1 by V plus 1 by U is equal to 1 by F. So this is the desired mirror formula relation. So I hope you have understood this. So in next video we will go over the magnification and all. So for more information, continue to our video section. Thank you for watching my video. Thanks a lot.